Hello Math 8 students, this is Utah Middle School Math Project 2.3 on proportional triangles and slope. To get started, we have this line here at the right, and I want you to pick any 2 points that lie on the line. However, even though it says any 2 points, please make sure that your points lie on intersecting grid lines. What that really means, I've always called those crosshair points. For example, this is a great point to choose because it lies in intersecting grid lines or at the crosshairs. This one right here would not be a good one because it doesn't go through those crosshairs or those grid line points. So pick any 2 points. I'm going to pick points. I want you to try and choose points different from mine. I'm picking these ones because they lie in the crosshairs. Try and pick different ones for me. And as you pick them, you're going to create a right triangle, just like you see down below and like we saw in our last lesson. We're creating a right triangle. This is the hypotenuse, and what that means is I'm going to be drawing a line that goes straight up. Did you go down? That's okay. I like to draw mine above the line. I'm going to go straight up and straight across. That way you can see that they meet at a right angle. You can go down, yes. And that was really, really small, so if I'm trying to do it a little bit bigger, I maybe would choose this one because I can see it lies at a crosshair point, and this one because I can see it lies at a crosshair point, and I would be going again, I'll do it the way that you guys did it, straight over if you want, and straight down. And again, we can see that they meet at a right angle. Those are just 2 examples. What I want you to do now is compare the points that you chose and your triangle with someone else in class. Discuss the following. Did you both choose the same points? How are your triangles the same? How are your triangles different? What relationship exists between the triangles? Discuss with your groups. Online learners, pause the video until you've had a chance to think about your response to those questions. All right, what are your thoughts? Did you guys choose the same points? Anyone in the groups? Okay, a few of you chose the same point. So that means most of us should have different triangles, right? Are the triangles the same in any way, though? How are they the same? Garrett, what would you say? Okay, so you guys both had an up to and over 1 type triangle? Okay, so even though they were different points, they were the same size triangle. Great. How else would we have seen some things? Landis? Yeah, they are both right triangles. They both have right angles. Anything else that was the same? Xander? Yeah, all of them would be the same angles. Yeah, we know that because of what we saw in our last lesson, right? And that leads to the next question. What relationship exists between the triangles? If they all have the same angles, then we know that they are similar. And if we know that they're similar triangles, then that also tells us that they're probably not congruent. Some of them may have been congruent, yes, but not all of them would have been congruent. We know they're dilations. Because that's the definition of similarity, is that we can do dilations. Sure. So, again, take a look at these 2 triangles here. What we can see is what we're going to be discussing here below. And I'm going to be highlighting here. This is kind of sort of like the grand takeaway. It's almost like we're putting our summary in the beginning. But as we read through, there's a word that's a little bit weird. So I want you to add, before we start highlighting, we're going to draw a diagram. And it's going to look like this. What I'm drawing is a right triangle. A right triangle is a triangle that has a right angle. So that's what I've drawn here. And in a right triangle, it's a special kind of triangle because it has a right angle, and the side that is across from that right angle also has a special name. That name is hypotenuse. Hypotenuse. It's written down here, and I've written it up here. We're going to talk a lot more about the hypotenuse at the end of the year. That'll be one of the final units that we talk about. But for right now, I just want you to understand what it's talking about when it's talking about the hypotenuse. So in this right triangle, The hypotenuse is the only one that has a special name. The other sides don't have special names. They're just called legs. The legs of the triangle are the ones that help to form that right angle. Okay, so right angle is formed by the legs, and opposite that right angle is the hypotenuse. So what we need to make sense of is this. It says given any two triangles with hypotenuse on the given line and legs horizontal and vertical, basically it's saying any of the triangles that we could have created here, because we have a leg horizontal, leg vertical, and notice the hypotenuse of each one. Do you see how it's on the line? That's all that it's saying. When we have that situation, we know that there is a dilation that would take one to the other, which tells us, we remember that that means these are similar. And so it says, in particular, the lengths of corresponding sides are all multiplied by the scale factor of the dilation. And so the ratio of the length of the vertical length to the horizontal length is the same for both triangles. This is the key takeaway here, which we have observed and phrased in our other lesson just a little bit differently. We recognize that that is the vertical length divided by the horizontal length, because that's what a ratio is. It's just a comparison, so I'm comparing through that division. And in our last lesson, we started to call it something else. Instead of vertical length, we started to call it the rise. And the horizontal length, instead of calling it horizontal length, we started to call it the run. Now the question that I have for you is, see if you can remember, what is the name of this ratio? It has a special name. What is the name of this ratio? Nobody did their homework. Nobody paid attention last lesson. Landis. It is slope. Very good. So this ratio has a special name. That ratio is called slope. And it's going to be the same for all of the triangles that we can make that lie on that line. We're going to prove that it's the same in all of these next examples. So let's move on. We are going to be wanting our colors. We'll use about 4 to 5 colors here. Yep, and I'm going to do the first one with you. So number 3, we're going to work on together. Then you are going to work with your groups on 4 and 5, and then we'll do number 6 together too. Okay, here's what this looks like. I'll wait until I get voices off. You guys should not be talking when I am. The graphs given below have several different triangles formed from 2 points that lie on the line. We're going to answer the questions. First, how many triangles are there? Knowing how many triangles there are is going to be helpful because that's how many ratios we need to start. So I can see this point on the line and this point on the line, so I made that into a triangle. Do you see that little itty bitty baby triangle there? Okay, that's going to be one triangle. And I'm going to write the ratio of the rise over the run, that vertical length over the horizontal length. What is the vertical length here? 1. And the horizontal length? 1. And what's 1 over 1, or 1 divided by 1? That simplifies to 1. Yep, next triangle. This is where I'm using the colors to show the different triangles that I'm looking at, and then showing that same ratio, or the ratio for that triangle in the same color. Yes, Landis, you already know what's going to be happening. Great prediction. Let's count this ratio. We're counting the rise, we're counting the run. Count it with me. 1, 2, 3, 4, 5, 6, 7. And the run is 1, 2, 3, 4, 5, 6, 7. And 7 divided by 7 is 1. Huh, that's interesting. It's the same as it was up here. Next triangle, next color. Here's another triangle. Going all the way up to this point here. And I'm counting the rise and the run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 7, 8, 9, 10. So the rise of 10 divided by the run of 10 is equal to 1. They should all be 1, right? That's what it just said on our summary that we already highlighted, so I'm hoping that they should all be 1. This is just really good practice for us in identifying the slope, which is a big part of your test. Voice is off. Last one. Let's count the rise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 13 over 13, how about that? It's also 1. Pretty easy, right? So like I said, this next part you're going to do by breaking it up amongst your group. What I suggest is one person can do number 4, and the next person can do number 5. That way we're getting all the work done, but in half the time. We'll do number 6 together. Online learners, pause the video until you have done 4 and 5. We'll return to the video once we're done with that to go over it all. Pause the video now. Okay, we're back. Take a look at the answers for number 4. I can see my rise and my run for each of these triangles. I have color coded them. So I've got my smallest red triangle up to, the rise was 2 and the run was 6. So 2 over 6 is 1/3. And the next biggest triangle simplifies to 1/3. And the next biggest triangle simplifies to 1/3. And the biggest triangle still simplifies to 1/3. Number 5. I have a rise of 4 and a run of 2 for my smallest triangle that I did in red. So a rise over run of 4 over 2. 4 divided by 2 simplifies to 2. And we can see the same thing for each of these triangles, color coding the triangle to match the ratio. And they all simplified to 2. Let's do number 6 together. Can you count all of the triangles here? There's a lot, more than you think. Let's start with this one. This one, I just did it in red. Smallest itty bittiest one. Did you even see that one? A rise of 1 and a run of 1 means 1 over 1 is equal to 1. Here's your next triangle. Did you see this guy? And here we have up 1, 2, 3, and over 1, 2, 3. 3 over 3 is equal to 1. Yes, Camden, you're making very good observations. Those are exactly the observations I want you to make through this lesson. Do you see this one? And we have a rise of 1, 2, 3, 4, and a run of 1, 2, 3, 4. 4 over 4 simplifies to 1. 4/4 simplifies to 1. Next one here. Do you see this one? Okay, and this one here. 2 over 2 is 1. Let's go to some new colors. How about this one? There's 2 more. Can you guys see them? You see 3 more? Do you see this one? One, 2, 3, 4, 5. And the run is 1, 2, 3, 4, 5. 5 over 5. Yes, they are all 1. That's exactly what I want you to see and to understand. Great job. Last triangle is the big one. And we see a rise of, count it, 1, 2, 3, 4, 5, 6, 7. And a run of 1, 2, 3, 4, 5, 6, 7. 7 over 7 is 1. If you haven't figured this out yet, then I certainly hope that you did today. Do the ratios of rise to run always simplify to the same fraction? Don't even worry about this. I don't like those words. We're ignoring those words. Do they always simplify to the same fraction? Yes. They always do. Why? Well, because like we have mentioned multiple times before, because these triangles are similar. These are similar triangles. So similar triangles have proportional sides. Proportional sides. And now here's the next question for you. I'm going to ask number 8 in a little bit different way. I want you to look at these 4 lines, okay? 3, 4, 5, and 6. I want you to point with your finger on your own paper. Will you please point to the line that is the steepest? 3, 4, 5, 6. Point to the line that is the steepest line. Are you pointing to it on your own paper? 3, 4, 5, and 6. Now, with your other hand, point to the line that is the least steep. Okay, now answer me this question. Which one is the most steep line? 3, 4, 5, or 6? Cole? It is 5. 5 is the steepest. Which one is the least steep line? 3, 4, 5, or 6? Maddie? 4. Very good. Now, let's make a connection then. Which ratio is the greatest number? Point to it. Which ratio is the biggest number? Now with your other hand, which ratio is the smallest number? Do you make a connection here? Which ratio is the biggest? Number 5, because it has a ratio of 2, and 2 is bigger than 1, which we see here, and bigger than 1, which we see here, and bigger than 1/3. You see where I'm going with this, Garrett? Okay. Exactly, and so this was the least steep line, and so what do we notice? It is the smallest number. Let's write that down. Because it's asking, how does the rise over run ratio, remember that's our slope, how does it describe the steepness of the line? The greater, I'm going to give myself a little bit more room here, the greater the slope, the steeper the line. So if I didn't give you graphs to look at, and I told you that this one had a slope of 1/3, where did my mouse go? This one has a slope of 1/3, and another line has a slope of 2, would you be able to tell which one is the steeper one without even looking at the graph? Yeah, because we just look at the number, right? That size of that number helps us identify the steepness. Let's move on to the next activity. And now I want you all believe me that all of these triangles are all going to simplify to the same, right? So can we just focus on just one, just to save some time? Good answer. So I want you to do the same with just this smallest triangle in each one. I'm highlighting it red. Rise over run for each one. Write it down on your paper. Discuss with your groups. I know you have an observation. That observation is coming up next, so just hang tight. He doesn't want to steal your learning, so he's going to keep it to himself for right now. Again, we're trying to compare the rise and the run. This has a rise of, count it, 1, 2, 3. A run of 1, 2, 3, 4. This has a rise of 1, 2, 3, and a run of 1, 2, 3, 4. So the rise over run here is 3 over 4, which does simplify to the fraction 3/4. And what about here? Rise is 3, the run is 4, so it simplifies to 3/4. Number 11 asks us, why is it that 9 and 10 have the same ratio, but they're different lines? Talk to each other about what's different. Okay, come back to me. Why are they the same ratio, but those lines look very different, don't they? What's different? I'll wait till we get a few more hands. Good. Cambry. Yes, you're right. The triangles are on different sides of the line. And there's a reason we drew those triangles on different sides of the line, but it will make sense if we have a little bit different way of explaining it. Who else could describe something that's different about those lines? Landis? You said the same thing as Cambry. We have the triangles on opposite sides, but let's really look at why. Cole? Nope, it's not. It's actually not a reflection. Not even close. But good guess. I like the math word at least. Xander? No! It is a rotation. But no, I don't want to talk about rotations either. Is it a rotation? Now my brain is hurting. It's a reflection over the horizontal line. It's not a reflection over that line, so it's more a reflection than a rotation. Okay, voice is off. Voice is off. Eyes on the screen. Let's remember, first of all, let's remember this. Which way do we read? Left to right. So how should we be reading graphs? Left to right. Reading graphs is no different than reading English. We read from left to right. So let's start on the left side of this graph. You are a person. And this is the hill that you are walking on. Let's read from left to right on this graph. You are a person, and you are walking on this hill. What is the difference? We're going which direction here? Down, and which direction here? Up. So that's why we saw the triangles the way that we did, is because what's happening to this line? This line is going down. As I go from left to right, I also am going downwards. No, I intentionally did not make a square because I didn't want you to find and think that that was something special. What about here? When I'm moving from left to right, what is happening? I'm also going upwards. Because we need to remember that we read from left to right. So this is going downwards and this is going upwards. What is the main difference is number 9 goes down and number 10 goes up. But please also make sure that you remember it's because we read from left to right. Would you rather be the person that walks down this hill or the person that walks up this hill? Down. It's going to be a lot less effort, right? Walking up the hill is going to be a lot of effort. So tie that into this. How am I going to differentiate between the slopes of these lines? Remember, we're looking at the ratios. They do have the same ratio, but how do I tell the difference between the slope? Because they're different. One's going up, one's going down. What could I do to show that upness and to show that downness? Talk to your groups. Just a quick 20-second discussion. Ready, set, go. Okay, voice is off. Come back to me, please. How can I show that these are different using just that ratio, using the numbers? Garrett, what are your thoughts? I don't want to never mind. I want your thoughts. Let me remind you, you have a test coming up. This is time for your brains to start working, making some connections. How can I differentiate between these two? Are they the same if one is going up and one is going down? Then how can I show that one is going up using those numbers? How can I show that one is going down using those numbers? Mason? An arrow? Not too bad. But do we normally have arrows in our numbers? No. We do with our lines, but looking at just this. The line is gone. All you have is this. If all you have is this, how do you know that it's going down? We wouldn't draw an arrow if all we have is a number. Cambry. Yeah, it was such an obvious thing. I'm surprised that nobody else came up with that. How do we do this? By showing that 1, the downwards one, would be negative. And the upwards one would be positive. And we're going to make some more connections with this tomorrow. But before we end this video and before we dismiss for the day, I want to show you how we're already doing this work. Okay, so take a look. I'm going to now move to the middle triangle because we know that it's going to be the same. But notice, which direction am I going? So if I'm going from left to right, which direction am I going right now? Down. So it's not just 6. Now it's 1, 2, 3, 4, 5, -6 because we're going down. And as I count across this way, which direction am I moving? Left or right? Right. And right is a positive direction. So over 1, 2, 3, 4, 5, 6, 7, 8. So that would be a positive 8. Now you tell me, what is a positive, or excuse me, a negative divided by a positive? It's always negative. So -6 divided by 8. 6/8 simplifies to 3/4, but it's not just 3/4, it is a negative. And notice where I put that negative. You can keep it in the top in that numerator, but really traditionally we like to put it in the front because remember, this negative means it is going downwards. And let's compare and contrast that to this one. Again, I'm going to look at that middle triangle now just so that it doesn't get too crowded. Which direction am I going? Which direction am I going? Up. So this is a +6. And now which direction am I going? Right, which is a positive direction. So +6 divided by a +8. And a positive divided by a positive is a positive. Now you can include that positive sign. You don't have to. We normally don't when it's a positive number, but I'm doing it here just so that we recognize that when it's a positive number, that means the line is going upwards. I'm running short on time, but I want to do just one more super duper quick, okay? Let's take a look at this positive one more time. What if we are silly gooses and we look at it a little bit weird and we're like, I'm going to go to the left. How much did I just go to the left? That's 12. But left is which direction? Negative. So I went -12 for my run. And because I went left, now I have to go down. How much did I go down? 9? Okay. And down is also a negative direction. What's a negative divided by a negative? Also positive. So even if you make a mistake and you go left and down, guess what? It corrects itself. It still ends up being positive here. And again, I'm going to be silly goose and make a silly mistake here just so that you guys can see. Let me switch to this color now. What if here I did the same thing and I went left for my run? That's going to be a negative, what is it, 12? But then I would have to go which direction here? Up is a positive, and that's going to be +8. So what if I did that? That's going to be a +8 over a -12. But what's a positive? Is it 9? Thank you. Yes, you're right. You're right. It is 9. What is a positive divided by a negative? It still ends up being negative. So that's the nice thing, is even if you make a mistake and you kind of go in reverse order and you're not going left to right, it self-corrects. A positive divided by a negative is still a negative number. All right, there is one last question, but we are going to skip it for now just for the sake of time. You know exactly what you need to do for your homework because it is very similar to what we just did in class. So 2.3C homework section, make sure you complete that and get that submitted. Thanks for watching. We will see you next time.